Good day everyone. So we are here to discuss to you the solar powered home. So meron tayong tatlong configuration ng solar powered home. So meron tayong grid tied, off-grid, and hybrid. So si grid tied is hindi na siya konektado sa traditional utility grid and wala siyang battery for backup or for any storage. Then si off-grid naman is isa siyang standalone system. So bakit ba natin nasabi na standalone system siya? So since si off-grid is hindi na konektado sa traditional utility grid and meron siyang large sets of battery na mag store ng energy during the day and gagamitin niya yung energy na na-store niya sa night times or when sunlight intensity is low. Then si hybrid naman is combination siya ng grid tied and off-grid. Since si hybrid is konektado pa siya sa traditional utility grid and meron din siyang battery backup. So yung backup na yon is para pag nagkaroon ng power interruption is patuloy pa rin gumagana ang ating system. So focus tayo sa grid tied. So si grid tied isa siyang solar power system na konektado in parallel sa ating electric supply na papunta sa ating bahay. So any excess energy na mapoproduce ng ating grid tied is being fed to the grid. Then, alam natin na walang battery backup ang ating grid tied. Kaya naman, hindi siya magpo-produce ng power at night. Then, during brownout naman, dapat naka-shutdown state ang ating grid tied. Then, ang main purpose ng grid tied is para makapag-save ng electricity. So, when in fact, pag ang ating solar array ratings is nag-match sa ating electric consumption, is zero bill can be attained. So, meaning nun, maaari na wala tayong bayaran. Then, possible din na pag ang ating grid tied is solar array rating is mas tumaas kaysa sa ating electric consumption, maaaring tayo pa ang bayaran ng ating distribution utility na ating kinokonektahan. Ito ang representation ng isang solar-powered home. Next. So, sa parts. So, meron tayong solar panel, grid-tied inverter, pwedeng with or without limiter, square wave or pure sine wave. Meron din tayong DC circuit breaker, DC surge protection device, AC circuit breaker, AC surge protection device, time delay switch, DC-AC electrical wires, MC4 connectors, solar rail, and then clamps. So, ang DC-AC electrical wires hanggang clamps is mga maliliit na components na lang yan ng ating solar-powered home. So, magpo-focus tayo sa may solar panel hanggang time delay switch. So, unahin na natin ang solar panel. So, sa solar panel naman, na-discuss na natin kung ano ang working principle niyan, kung paano siya gumagana hanggang sa kaloob-looban niya. Kaya naman, pasadahan na lang natin siya. So, ang solar panel is ang heart ng solar-powered home. Sabi dito na ang typical solar cell ay nagpo-produce lamang ng half a volt. So, by connecting them together in series inside the panel, a more usable voltage is achieved. Then, yung most small solar panels na rated 150 watts or below is nagre-rated as 12 volts. While yung mga larger naman is nagre-rate at 24 volts. A 12 volt solar panel produces around 14 to 18 volts when put under load. Kaya naman nakakapag-charge siya ng 12 volts battery. Pag naman tinanggal mo ang load, so maabot yung readings niya up to 26 volts. So normal lang naman yon sa mga open circuit na solar panel. As soon as binalik mo yung load, babalik na siya sa kanyang normal na operating voltage. Next. So, sinasabi lang dito na si solar panel daw is can be connected together to create a solar array. Sabi nga na ang solar cell natin is half a volt lang yun na po-produce. So, ang naging solusyon doon is connect them in series. So, para mas makabuo tayo ng mas malaking output, so pagka-connect-connectahin natin ang solar panels into array. So, yung output of solar array natin is computed much like a battery. Pag siniris connection mo ang ating solar panel, so tataas ang volts, then yung current is remain constant. Pag in parallel naman, magre-remain constant ang voltage and then tataas ang ating current. So para mas maintindihan, let's take an example. So sa next slide natin, makakita tayo ng mga solar panel. So assume natin na sila ay 12 volts and then 10 ampere. So unahin natin dito sa PV panels in series. So pag may sabi doon na meron tayong 12 volts and then 10 amperes. So, Alam natin sa series, pinagpa-plus-plus ang ating voltage. So, meron tayong 12 plus 12 plus 12 which is 36. Tapos, ang current natin ay remain constant which is 10 ampere. So, 12, then 10, 12 plus 12 plus 12, 36. Tapos, ang ating amperahe is 10 ampere. Kaya naman, meron tayong 36 volts, 10 ampere, then, ang ating power which is P is equals to I times V lang naman which is 360 watts. So, dito naman sa nakaparallel. So, pag nakaparallel naman, meron tayong 12 plus 12 na solar panels, 12 volts na solar panels, and meron tayong 10 amperes. Since nakaparallel to, i-add natin ngayon ang ating current, which is 10 plus 10 plus 10, which is 30. Tapos ang ating voltage is magre-remain constant, which is 12. So, 30 times 12, which is 360 watts din. So, makikita natin, regardless of the connection, same ang ating output power. So, next, dito tayo sa power panels. So, meron tayong 12, 12, 12, 12, which is 12 plus 12, 24. Since parallel yan, ang buo na to is 24 volts na lang. Then, nakaparallel yan, kaya naman meron tayong 10 and 10, which is 20. 24 times 20, which is lalabas na power is 480 watts. Pag naman, yun nga, nasabi na natin sa nakaparallel. Pag naman pinarallel nating ang lahat na ito, so assuming lang wala dito sa picture, so pag parallel to lahat, meaning 12 voltage is constant, and then yung kanyang current is mag-a-add, which is 10 plus 10 plus 10 plus 10, which is 40 ampere. Kaya naman, ang P natin is equals to B times I, which is 480 watts. So, makikita natin dito na regardless of the connection, same output power lang ang lalabas. So, ang tataas lang dito ang kanyang voltage or kanyang ampere. So, dito kasi, dito natin makikita kung anong connection ba ang kailangan natin. Depende sa pangangailangan ng ating susuplayan. So, yun. Next, so solar panel type. So, alam din na din natin to na meron tayong polycrystalline and monocrystalline. Then, si monocrystalline, to make cells for monocrystalline, silicon is formed into bars and cut into wafers. Then, si polycrystalline naman, fragments. So, kung pagbabasihan naman natin ang kanilang cell structure or kung paano nabuo ito. So, si monocrystalline is binubuo ng pure silicon crystal while si polycrystalline is binubuo ng fragments of silicon crystal. So, pag-usapan naman is color. So, makikita natin na si monocrystalline is black hue while si polycrystalline is blue hue. Pag naman, in terms of life expectancy is, si monocrystalline is 25 to 40 years while si polycrystalline is 25 to 35 years. Dahil si monocrystalline is binubuo ng pure silicon crystal, kumpara kay poly na binubuo ng fragments of silicon crystal, so masasabi natin mas efficient si monocrystalline. So pagdating naman sa performance when exposed to heat, so mas lamang si monocrystalline kumpara kay polycrystalline. So dahil nga pure si monocrystalline, mas mahal siya kumpara kay polycrystalline. So next is
Modified sine wave inverter. In pure sine wave inverters, the AC power produced by the inverter very closely matches an actual sine wave. In modified sine wave inverters, the polarity abruptly switches from positive to negative. When looking at the wave, it has a stair-step square pattern where the polarity is flipped back and forth. That choppy wave can negatively affect more delicate sensitive equipment. If you have a medical equipment you need to power such as a CPAP machine, you won't be able to use a modified sine wave inverter. Additionally, in many cases, you'll hear a hum with device attached to a modified sine wave inverter. The only advantage of this type over the pure sine wave is that this is much cheaper. So, pinagkaiba ng modified sine wave inverter is hindi siya steady like yung pure sine wave inverter. And ang advantage lang nito is mas mura siya kasi hindi nga siya steady or mahihina lang yung kanyang ano. Like for example is ang ila-light up mo is mga ilaw lang. So pwede mo magamit si modified sine wave inverter. And ito ang visual representation ng dalawa. So makita dito si pure sine wave inverter is smooth, while si modified sine wave inverter is parang kahugis din na sine wave but much more straight or parang nga siyang staircase kaya nga sa unang slide. So this is circuit breaker. So ito itsura ng isang direct current circuit breaker. So ang gamit nito is this is placed between the solar panels and the inverter or in some cases built into the inverter. Just like a typical circuit breaker, it acts as an overcurrent protective device. So in summary, ang circuit breaker is protect niya yung isang equipment from overcurrent, which is yung circuit, short circuit. So, meron din tayong AC circuit breaker. So, ito, DC, direct current circuit breaker. And ito naman is alternating current circuit breaker na ang ginagamit natin ay RCBO type. The AC circuit breaker are placed after the inverter. Just like a typical CB, it acts as an overcurrent protective device due to short circuit and overloading. See, RCBO stands for Residual Current Operated Circuit Breaker with Overcurrent Protection. In the RCBO type, it has added protection since it can sense earth leakage current where the typical breaker cannot. It has the capability to trip when somebody touches a live wire, thus protecting people around it. It may also serve as manual switch if there is a need to turn the solar power system off. So just like the DC circuit breaker, it protects the device from overcurrent and na ito yung short circuit and overloading. Ang pinagkaiba lang ng AC circuit breaker sa DC circuit breaker ay gumagamit ito ng RCBO, which is nakakasense siya ng earth leakage current. So meron naman tayong DC surge protection device. So ang pinaka malinaw na explanation sa direct current surge protection device is pinoprotect niya ang isang device from over over voltage or voltage surge or power surge or ang pinaka ginagamit na term is ang voltage transient. So the AC SPD are placed parallel to the AC CB. Just like the DC SPD, this serves as protection against transient voltage yun nga. But this time on the AC side of the PV system, SPD redirects the excess power to the ground multiple equipment connection. On the grid, either internal or external, can also be cause of electrical anomalies where power surge could also arise. So ito naman yung AC circuit breaker, AC surge protection device. So ito naman is time delay switch. This can also be called as a power on delay. It delays the turning on of any electronic device for desired time interval. This device serves its use purposely usually when brownout occurs. After a brownout, when power have already been restored, this is the tendency of power surge which may damage the system if it is being turned on right away. So ang nagagawa lang ng time delay switch is dinedelay niya yung pag-on ng isang machine. For example niya sa sinasabi dito, pag nagkaroon ng brownout at nagkaroon ng kuryente after brownout, is hindi niya muna i-on yung mga machines kasi pwedeng mag-cause ito ng power surge. Turning the solar power system on and off could be a vital routine which cannot be perfectly done in a day-to-day basis. Programmable timer is a hassle-free switch that automatically turns the system on and off at your desired time. So ito naman is programmable timer switch. Pwede mong iset yung time ng pag-on at off ng isang device. For example is yung sa aircon. Pag pwede mo siyang iset na pag 5 AM na is mag-automatic siya na mag-off or mag-automatic siya mag-on if 8 PM na. The net metering. What is net metering? Net metering allows customer of distribution utilities or DUS to install an on-site renewable energy facility not exceeding 100 kilowatts in a capacity so they can generate electricity for their own. Any electricity generated that is not consumed by the customer is automatically exported to the DUS distribution system. The DU then gives a peso credit for the excess electricity received equivalent to the DU's blended generation cost. So, ang net metering is magkakaroon ka ng karapatan magkaroon ng renewable source of energy which is hindi tataas sa 100 kilowatts. Like yung mga solar panel, pwede kang gumamit nun. And ang isang advantage ng net metering is yung mga excess na electricity na hindi magagamit is ibibigay sa distribution system and babayaran yung owner ng may renewable source for the excess energy. Is net metering already available in the Philippines? So yes, on 27th May 2013, the Energy Regulatory Commission adopted ERC Resolution 09 Series of 2013 approving the rules enabling the net metering program for renewable energy. This resolution was published on 10th of July 2013 in newspapers of general circulation in the country and took effect 15 days thereafter. Thus, the net metering rules took effect in the Philippines on July 24, 2013. The net metering program is available onto on-grid distribution system. What benefit will I get if I go into net metering? By generating electricity for own use, you reduce the amount of electricity you buy from your local DU. The rate of savings or avoided costs realized on electricity generated for own use is equivalent to the DU's retail rate costs consisting of charges for generation, transmission, system, distribution, subsidies, taxes, and other charges. You also earn peso credits on any excess electricity exported to the DU equivalent to the DU's blended generation cost. So, like sa what is net metering, sinasabi dito na ang advantage niya is magkakaroon ka na ng renewable source of energy and yung mga hindi mo pa magagamit is hindi masasayang, kundi ilalagay siya sa distribution system tapos babayaran ka for your excess of energy.
Question number 4. How will my DU monitor the excess energy that my grid-tied setup is exporting towards the grid? So, the DU may opt to install two unidirectional meters, one to meter energy you buy from your local DU, and the other to meter the energy you export to the DU. The DU may, at its option, install a single bidirectional meter that can meter both import and export energy if it's find it is to be more economical. The DU may also install a third meter in proximity to your RE facility to meter its total RE generation. The total RE generation shall earn for the host DU RE certificates, which the DU can use to comply with, with its Renewable Portfolio Standards or RPS obligations. Question number 5. Who are qualified to participate in the net metering program? DU customers who are in good credit standing in the payment of their electric bills to their DU are qualified to participate in the net metering program for renewable energy. These customers are referred to in the rules as qualified end users or QE. So, what are the consequences for not applying net metering? In case the solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. Example is when the solar array is rated at 5 kilowatts and the load consumption is only 4 kilowatts, the system will have an excess of 1 kilowatt, which will be sent to the grid. This excess energy will pass through the meter, hence will be billed to the owner. So another question is there any other way besides net metering that a customer having a solar power system producing excess energy during the day and yet will not pay for it? The answer is yes. This can be achieved by using an inverter with limiter. This device limits the power that the system will dissipates. It automatically detects the maximum power that the system can provide without the excess being sent to the grid. So here is the circuit connection. Next is the solar powered home grid tied circuit. So yan yung mga components nun. Next topic is about wire sizing. There are four types of wire types. First is the TW or thermal plastic wire. Its characteristic is moisture resistant and flame retardant. Same with the second wire type, which is THW or thermal plastic heat resistant wire. It is also moisture resistant and flame resistant or flame retardant. Third is THHN or thermoplastic high heat resistant nylon coated. It is designed for specific insulation materials, temperature rating, and condition of use, suitable for dry and damp locations. Next is THWN-2. Similarly to THHN, except it is water resistance, adding the W into the acronym. And lastly, PV wires or photovoltaic solar cables. It is intended for interconnecting power supplies within renewable energy photovoltaic system, such as solar panel arrays in solar energy farms. PV cables are manufactured in accordance with standard BSEE 50618 and are suitable for fixed installations, internal and external with conduit or system, but not for direct burial application.
Types of wires. PV wires. PV wires, also known as photovoltaic wires or solar wires, are specialized electrical cables designed for use in photovoltaic systems. These wires are specifically engineered to handle the unique requirements and conditions of solar power generation. It is important to use high-quality photovoltaic wires that comply with relevant safety and industry standards to ensure the reliable and safe operation of the solar power system. Next is American wire gauge cables. Ito lang yung mga size na mga cable. Temperature rating of conductor. Ayan, nakalagay naman dyan. Wire ampacity, temperature rating of copper conductor. Kapag kapag TW ay in 60 degrees Celsius, 15. Pag 14 gauge or American wire gauge is 15. Kapag 12 is 20. Dito naman sa 75 degrees Celsius, nakalagay naman dito yung mga types pag RHW or THHW, THW. Pag ang American wire gauge niya, pag 14 size is 20, kapag 12, 25. Ganon din sa 90 degrees Celsius. Nakalagay naman dyan yung mga types. Next is ambient temperature correction factors based on 30 degrees Celsius. Kapag yung ambient temperature mo is 11 to 15 ay 1.22. Kapag naman sa 75 degrees Celsius is 1.15. Kapag 19 degrees Celsius is 1.12. Next is the ambient temperature adjustment for raceways or cables exposed to sunlight on or above rooftops. Distance above to bottom of raceways or cable. On roof 0 to 13 millimeters is 33 degrees Celsius or 60 degrees Fahrenheit. Above roof 13 millimeter, 22 degrees Celsius or 40 degrees Fahrenheit. Kapag naman above 90 millimeter to 300 millimeter, 17 degrees Celsius or 30 degrees Fahrenheit. Kapag naman above 300 millimeter to 900 millimeter, 14 degrees Celsius or 25 degrees Fahrenheit. Next is adjustment factors for more than 3 current carrying conductors. Number of conductors. Kapag 4 to 6 is 80. Kapag 7 to 9, 70. 10 to 20, 50. 21 to 30, 45. Kapag 31 to 40, 40. Pag 41 and above, 35. Next is American wire gauge cross-sectional area in centimeter. And makikita naman natin yung mga nasa table. Next is standard ampere ratings. Standard ampere ratings is 15, 20, 25, 30, 35, 40, 45, 50, 60, 70. It is a standard ampere ratings for fuses and inverse time circuit breakers. Steps in photovoltaic system conductor sizing. First is look for the ISC rating of PV cell. Second is multiply by 2 safety factors, irradiance and continuous duty. Third is refer on table 310.15 for the size of wire. And the fourth, for opacity correction due to ambient temperature more than 30 degrees Celsius. And fifth, for ambient temperature adjustment due to conduct or wires distance from the roof. 6 is for adjustment due to more than 3 wires inside a conduit. 7, find the adjustment due to voltage drop. And last, the value obtained is the last step will be the basis for the size of wire to be used in the photovoltaic system. PV cell specs. JA Solar is a common photovoltaic. Next is sample problem. For the IEC rating of PV cells is Step 1, look for the IEC rating of PV cell. Step 2, multiply by the two factors, irradiance and continuous duty. Step 3, for the size of wire, table indicates for number 14 THHN with ampacity of 25 ampere. Next is find the proper wire size for a grid-tied photovoltaic system consisting of 3 JS solar panels connected in series with specs the next slide. Step 4, ampacity correction due to ambient temperature. Since Philippines ambient temperature is around 37 degrees Celsius. The table indicates 30 times 0.9 equals 27 ampere. Step 5 ambient temperature adjustment due to roof wire distance. For one half and above roof, 37 plus 22 equals to 59 degrees Celsius.
Simple problem in PV system conductor sizing. Find the proper wire for a grid-tied PV system consisting of three solar panels connected in series. So, step 6. Since there's only two wires inside the conduit, this step can now be bypassed. So, step 7. So, step 6, okay na yan. So, step 7, adjust due to the voltage drop. VD is less than 3%. Use the formula VD is equals to 2 IR or R is equals to K L over A. So BD, so substitute lang natin, 2.93 times 12.9 times 25 over 6,530 is equals to 0.92 volt. So sa percentage BD is equals to 0.92 over 32.26 times 100%. So makukuha na natin siya ng 2.85%. So sabi nga, so BD is equals to 0.92 over 96.78 times 100 is equals to 95%. 0.95%. Since 2.85 is less than 3%, our selected number wire our selected number 12 wire will fit the system. So sabi nga, since 2.85 is less than 3%. So, ang gagamitin natin dyan is 12. But since 2.85 is a bit near to 3, it would be better to use number 10, THHN wire for additional safety factor and for future expansion. So, kunyari, may gagawin pa tayo ron sa bahay na yun, or mag-adjust tayo ng bahay natin, syempre, magdadagdag tayo ng wiring. So, number 10 THSN will fit the system for the future expansion. So, on the previous problem, in case the voltage drop exceeded 3%, let's say 5%, the additional computation is as follows. Since the initial selected wire is number 12, THN, make a one-step higher adjustment. Select initially number 10, THN. So, formula ulit tayo. V sub D is equals to 2.93 times 12.9 times 25 over 10,380 is equals to 0.058 volts. So, sa percentage naman tayo. V sub D is equals to 0.05% over 32.26 times 100% is equals to 0.118%. Select number 10 THHN as the final wire to be used in the system. So THHN na gagamitin natin doon. So note, K is equals to direct current constant. This is a constant representing the direct current resistance for a 1,000 circular mesh conductor that's 1,000 feet long at an operating temperature of 75 degrees Celsius. The direct current constant value you should use for copper is 12.9 ohms and 21.2 ohms for aluminum conductors. The key constant is suitable for alternating current circuits where the conductors do not exceed number 1 of 0. So, sample wire sizing in chart. So, dito natin makikita ang dapat natin gamitin sa mga bahay-bahay natin or sa building ng wire sizing. So, kunyari, magpapatayo ka ng building, ano ba ang dapat ikabit doon? So, dito natin makikita. Magpapatayo ka ng isang bahay, ano ba ang dapat ikabit doon? Dito natin makikita at kukumputin natin upang makita natin ang tamang wire na bibili natin, ang tamang wire size or ang tamang pagpili ng wire. So next tayo. Inverter sizing. For the inverter to fit system, its power rating must be approximately equal to the power rating of the solar array, or maybe a bit greater of around 10% to 20%. Therefore, if your solar system is rated at 2000 watts, you'll need a solar inverter that is about 2000 watts. An inverter that is way below the power rating of solar arrays cannot maximize the power that the solar arrays are capable of. And an inverter that is way above the power rating of solar arrays will have not noticeable drop in efficiency. So sobrang ano naman ito ano na tawag dito. Self-explanatory ng ating ginamit na sentence. So, in our example, which rated at around 900 watts. So, ganito lang. 900 times 1.1 is equals to 90. So, use 1 kilowatts grid tie inverter. Kasi almost 1,000 na. So, magkikilo na tayo dyan. So, this AC circuits breaker system. First thing to consider in sizing is a CV or PV system is a ruling in PEC which state that PV circuit currents continues thereby the minimum OCPD rating is 125% of the maximum current PEC 2017 Article 6.1. So yan yung mga article na pinagkuhanan nitong ating statement. So therefore, in reference to the problem in conductor sizing on the DC side, the max current is 15.23 ampere multiplied by 125%. That is 19.04. Use 20 ampere CB. Titingnan natin hindi mga eksakto yung yung computation natin. Kunyari, hindi siya naging eksakto ng 20 ampere. Ayun, sabi nga dito, 19.04. So pwede na tayong gumamit ng 20 amperes for that current. Gagamit na tayo ng 20 ampere CB na wire. So on the AC side, since the inverter rating is 1 kilowatts, dividing this by 220 voltage, the current will be 4.5 ampere multiplied by 125%, that is 5.6625 ampere. Use 6A CB RCDO. So yun nga, tinan mo, kung mapapansin natin, hindi eksakto ang mga bilang natin ng current sa gagamitin natin na wire. Di ba? So, pwede tayong mag-approximate dyan. So, kunyari, 5.6, pwede na tayong gumamit ng 6 amperes. So, revisiting our number 10 THHN stranded wire, ampacity at 30 degrees Celsius is equals to 4 ampere correction due to ambient temperature. So 40 times 0.91 is equal to 36.4 ampere. Due to the roof wire distance, 37 plus 22 is equals to 59 degrees Celsius. So 36.4 times 0.71 is equals to 25.8 ampere. So surge protection device sizing. The rule is simple in sizing of surge protection device. So basically, the UC rating of the SPD should match the system voltage or a bit higher. Much more 15 to 25% for SPDs to attain a longer lifespan. Therefore, in reference to the problem conductor sizing, for the DCU side, use SPD with a UC rating of 100 volts to 120. So for DC daw, gagamit tayo ng 100 to 120 volts. For the AC side, sa AC side naman tayo, use SPD with UC rating of 230 to 275. So mas mataas siya. So, next tayo. SPD specification. In nominal discharge current, IMAX, maximum discharge current. UC, maximum continuous operating voltage, MCOV. So, UP, voltage protection rating, BPR, or surge voltage rating, or SVR, or clamping voltage. Surge protection device. Ito yan. Then, solar panel orientation. On those countries located in northern hemisphere, solar panels should be facing south direction for maximum sunlight, while in the southern hemisphere, it should be faced north. Since Philippines is above equator, it belongs to the northern hemisphere. The solar panels should be facing south direction for maximum efficiency. A general rule for optimal annual energy production is to set the solar panel tilt angle equal to the geographical latitude. Essentially, the closer a solar panel is located to the equator, the more the panel should be pointing straight up. The closer the panel is to the poles, the more they should tilt towards the equator. Therefore, in the Philippines, the solar panel tilts should be 12 degrees to 14 degrees. So zero bill computation. Compute your monthly average kilowatts. Use 300 kilowatts hour per month. Convert to daily usage 300 kilowatts hour per month divided by 30 days is equals to 10 kilowatts hour per day. So 10,000 watts. So 10 kilowatts per day. So, in the Philippines, peak hours is 5 hours a day. For solar array, rating 10,000 divided by 5 is equals to 2,000 watts. For zero bill assurance, 2,000 times 1.1 is equals to 2.2 watts. So, number of panels, 2,200 divided by 300 is equals to 7.33 is equals to 8 solar panels. So, that's it. Thank you so much.
Good day! So we are here to discuss to you the photovoltaic power system. So nung nakaraan, na-discuss natin ang solar thermal system which is nag-harness ng energy sa sun na kino-convert niya ito into thermal energy. Ngayon, itong si photovoltaic system is ito yung gumagamit ng energy from the sun and converts it into electricity. So, rekta electricity na siya. So, gumagamit ito ng solar panel para makapag-harness ng sun's energy. So, may dalawa tayong types ng solar panel. Meron tayong monocrystalline and polycrystalline. So, in terms ng kanyang fragments, so, si monocrystalline is binubuo siya ng pure silicon crystal. While si polycrystalline naman is fragments lang ng silicon crystal. So, binubuo siya nun. So, in terms ng kulay, so makikita naman natin na si monocrystalline is merong black hue, while si polycrystalline is merong blue hue. In terms ng performance, so mas maganda mag-perform ang monocrystalline kaysa polycrystalline since mataas ang kanyang performance pag na-expose siya sa heat kaysa kay polycrystalline. Kaya naman masasabi natin na si monocrystalline is mas efficient kaysa polycrystalline. So in terms ng lifespan naman, si monocrystalline is nagtatagal ng 25 to 40 years, while si polycrystalline is nagtatagal ng 25 to 35 years. So, yun. Components ng isang solar panel. So, meron tayong aluminum frame, tempered glass, encapsulant EVA, solar cells, encapsulant, EVA, backsheet, and junction box. So, kung magtatanong kung ano yung meaning ng EVA, ang EVA is ethyl vinyl acetate. So, ito ang mas onte or mas generalized na components ng isang solar panel. So, meron tayong glass, anti-reflection coating, metal grid, N-type and P-type silicon, and then metal plate. So, paano nga ba gumagana ang solar cell? So, let us start on the first thing that is happening inside the solar cell when sunlight strikes it. For maximum efficiency, kailangan mas maraming na-absorb ang iyong solar panel. Pag marami ka na-absorb, mas maraming energy ang iyong masusupply. So, here's the thing. Pag daw tumama ang sunlight mo sa top layer ng ating solar panel, which is glass, 5% na agad yung nawawala due to reflection. So, paano ba natin mami-minimize yun? So, dyan papasok si anti-reflection coating.
How do solar cell work? So, scenario to be avoided. To prevent losses due to reflection, this happens when coating is incorrect. So, pag wala tayong coating or mali yung pagkakalagay ng coating natin, pinapakita na dito na i-capture ng solar panel yung light pero magre-reflect yung light which is pwedeng lumabas ulit yung light. So, dalawa lang yan. Sabihin natin na may dalawang may dalawang light which is yung isa nag-pass through while yung isa is nag-reflect. While yung nag-pass through is magre-reflect ulit siya tapos magba-bounce back siya paloob. Pero yung nag-bounce back ngayon is may lumabas pa rin na light due to the incorrect nga na coating ng light prevention. So with the right amount of coating, the reflected energy can be minimized if not totally canceled. So dito naman pinapakita na kapag tama yung pagkakalagay mo ng coating is hindi siya totally ma hindi siya totally makaka-capture lahat pero halos halos malapit na sa zero yung mare-reflect na light. Kasi pinapakita dito na maka-capture niya yung light and mag-reflect man yung light, babalik lang din and very little light lang ang makakawala sa solar panel. Anti-reflection coating. It lets the light in but mostly it doesn't let the light to be reflected out. So sinasabi na mostly lang, hindi siya always, but mostly. It also makes some of the reflected light to get back. Certain manipulation is being done during manufacturing to achieve that characteristics. So why not let the sunlight directly strike the silicon? So ba't nga ba hindi na lang idiretso ang sunlight sa silicon? Which is mas lalo makaka-capture sun, di ba? Pag direct siyang pupunta sa silicon. Yun ay incorrect kasi the silicon being a semiconductor is a bit shiny. Exposing it directly to sunlight may lose about 30% of the sun's energy to reflection. So yung silicon niya as a semiconductor, shiny siya and 30% na kagad ng power mo ang mawawala due to reflection. Now here's a question. What's the main thing that is happening inside the solar cell or photovoltaic cell that is why it is able to produce electricity when sunlight strikes it? Let us first define what photovoltaic effect is. The photovoltaic effect is the generation of voltage, electric current in a material upon exposure to light. It is a physical and chemical phenomenon. To achieve a photovoltaic effect, we need a material which, when struck by sunlight, will exhibit some characteristic of a conductor. So, ano nga bang element ang pag na-struck siya ng sunlight is parang magiging conductor siya. So, dito is sinasabi na that, that particular characteristic of a conductor where there are number of electrons that moves freely is what should be attained to exhibit the photovoltaic effect. This is where the silicon semiconductor comes into place. So, sinasabi nga dito na ang element na mag-exhibit ng characteristic ng conductor is yung silicon, which is a semiconductor. When the silicon semiconductor absorbs energy from the sun, the photons which the sunlight have pull knock an electron out of its orbit within an atom, making it free to move within the system in random.
So, another thing that is needed to achieve by the silicon semiconductor is for it to exhibit the characteristics of a battery where there is an imbalance of charge on both sides. Therefore, two sides should be created. The so-called PN junction, making the two sides of the junction positively charged and negatively charged. Pure silicon is not enough to achieve this. This is achieved through doping. So, doping is the addition of other substance in a semiconductor for the purpose of modifying its electrical conductivity. So, let's have a review questions. So, what is happening inside a copper conductor when there is no presence of voltage across it? So, the answer is its valence electron is free to move, transferring from one atom to another in random. Next is, what substance should be used as dopant for the silicon to become negatively charged? And what substance should be used as dopant for the silicon to become positively charged? So, first, this is the lattice structure of silicon with phosphorus as dopants. And here is the lattice structure of silicon with boron as dopants. So on the N-type side, the phosphorus is being used as doping materials, while on the P-type side is boron.
On the N-type side, phosphorus being used the doping materials, while on the P-type side is its boron. The P-N junction. Phosphorus is a doping material which is positive, and the boron is a doping material which is negative. Since there is a rush of electrons from the N side towards the P side, the charge of the two sides will be reversed, making the boron dope P side become slightly negative and the phosphorus dope N side slightly positive. Depletion region. Depletion region is also known as the depletion layer. It's a region that forms at the junction between two different dope regions in a semiconductor device such as PN junction. In a PN junction, the depletion region is created due to interaction of majority and minority charge carriers. When a PN junction is formed, electrons from the N side diffuse to the P side and holes from the P side diffuse to the N side. This diffusion process can continues until the majority carriers from each side combine and neutralize each other. As a result, the depletion region is formed characterized by a lack of mobile charge carriers. The depletion regions contains immobile ionized atoms or dopants. The immobile positive ions in the N side and the immobile negative ions in the P side create an electric field across the depletion region. Next is, this rush of electrons will quickly form a barrier between two sides called depletion region. In here equilibrium is being reached, the electron stops flowing. An electric field is definitely created. The silicon junction is now exhibiting a characteristics of a battery. On the N-type side, phosphorus being used the doping materials, while on the P-type side is its boron. The P-N junction. Phosphorus is a doping material which is positive, and the boron is a doping material which is negative. Since there is a rush of electrons from the N side towards the P side, the charge of the two sides will be reversed, making the boron dope P side become slightly negative and the phosphorus dope N side slightly positive. Depletion region. Depletion region is also known as the depletion layer. It's a region that forms at the junction between two different dope regions in a semiconductor device such as PN junction. In a PN junction, the depletion region is created due to interaction of majority and minority charge carriers. When a PN junction is formed, electrons from the N side diffuse to the P side and holes from the P side diffuse to the N side. This diffusion process continues until the majority carriers from each side combine and neutralize each other. As a result, the depletion region is formed characterized by a lack of mobile charge carriers. The depletion regions contains immobile ionized atoms or dopants. The immobile positive ions in the N side and the immobile negative ions in the P side create an electric field across the depletion region. Next is, this rush of electrons will quickly form a barrier between two sides called depletion region. In here equilibrium is being reached, the electron stops flowing. An electric field is definitely created. The silicon junction is now exhibiting a characteristics of a battery.
So good day everyone. So we are here to present to you the solar thermal system. So first we define what is solar thermal system and how it differs from photovoltaic system. So solar thermal system is converts solar radiation to thermal energy, while photovoltaic system converts solar radiation to electricity. So, dito sa solar thermal system, dumadaan muna siya ng thermal energy, hindi siya rekta kuryente. Which is yung solar radiation na naging thermal energy is yun yung magpapagalaw sa generator na nakakonekta sa ating system. While sa photovoltaic system, yung solar radiation is rekta electricity na. Ang main component ng isang solar thermal system is ang kanyang collectors and hot water tank. So, solar collectors like solar panels ay ini-install din, pwede rin sa ibabaw ng ating mga bubong. Yung solar collectors na nagko-convert ng solar radiation to heat ay itatransfer ngayon sa hot water tank gamit ang isang heat transfer fluid. So, ang heat transfer fluid is maaaring glycol or water or combination of two liquids. Pero sa ngayon, hindi na ginagamit ang water kasi oonti yung heat capacity niya, no? So there are two types of solar collectors, may flat plate and evacuated tube. The question of which collector is preferred for your system is nakadepende sa location ng bahay mo, location ng pagtatayuan mo, at yung budget. So, if your solar thermal system does not generate enough heat to the hot water, a backup system will kick in. So, dito naman sa sinasabi dito na a backup system will kick in is ito yung hot water tank mo, which is dun ka mag-i-store ng energy. Kaya naman kung hindi ganun kalakas yung sikat ng araw, meron kang backup system na magpapagana sa iyong solar thermal system. So ang solar thermal system nga pala is tinatawag din na concentrating solar power, so CPS. So, what kinds of solar thermal system are there? So, there are two types of solar thermal system, which is ang active system na mas mahal kaysa sa passive system, but are also more efficient. So, the most common uses for this system are domestic hot water, swimming pool or hot tub, heating space, and heating system. Next, bakit nga ba maganda ang solar thermal and why go solar thermal? So the installation of solar thermal system will meet 90 to 100% of your hot water needs in the summer. Reduce your emission of greenhouse gases, lessen your dependence on non-renewable energy sources which are subject to price fluctuations, lead to long-term financial savings, and lead to marketing and public relation benefits for business. So yung una, yung meet to 90 to 100% ng yung hot water is ibig lang sabihin dyan is makakapag-store ka ng 90 to 100% ng energy dun sa may hot water tank mo, which is nakakailanganin mo na backup upang makapag-produce ng energy. So, next. So, types ng solar thermal system. Parabolic trap, solar tower, linear Fresnel reflector, and then lastly, ang parabolic dish. Ang parabolic trap is type siya ng concentrated solar power or yung CPS nga na system. Isa siyang long curved mirrors arranged in a line concentrate sunlight on pipes located at the mirror's focal center. So these pipes run down the length of the trap and contain an oil that is heated by the concentrated sunlight. This oil flows through the pipes to a power plant where it boils water. The resulting steam produces electricity in a conventional steam generator. During the course of the day, a motor rotates the mirrors to track the position of the sun. To limit intermittency and improve dispatch capability, this system may have molten salt storage or a co-firing natural gas system. So para mas maintindihan, ito ang itsura ng parabolic trap. So isa siyang long curve na mirror na merong concentrated or merong tube sa gitna upang makoncentrate doon yung solar radiation. So, ang working principle niya ay ko-collect siya ng solar radiation gamit ang kanyang collector na itututok dun sa may kanyang tube. Yung tube na yan is may laman na heat transfer fluid which is diretso ngayon sa may storage mo and then magkakaroon ng conversion doon, magiging steam ngayon yung water and then yung steam na na-produce natin is yun yung magpapaikot sa steam turbine na nakakonekta sa generator and yun na yun, magpo-produce na siya ng electricity. Then magre-repeat lang yung cycle.
So, ito ang isang example ng parabolic trap. Parabolic trap. So, pinapakita dito yung process ng parabolic trap. So, yun nga yung isang reflector na gumagamit ng mirrors, which is, ang shape nga niya is parabolic. Then, ang sunlight ay magi-strike dito sa parabolic shape reflected trap na mag-i-reflect naman niya ito sa central heat pipe. Ay, yung central heat pipe na yun is meron siyang nilalaman na heat transfer fluid. And yung heat transfer fluid na yun yung maglalagay ng naipon na heat na magja-generate ng electricity. So, dito nga, pinapakita yung sunlight, magi-strike siya sa parabolic trap na magre-reflect sa metal pipe na magiinit ng heat transfer fluid, which is yung heat transfer fluid na yon mapupunta siya sa heat exchanger. So yung heat exchanger na yon lalabas ulit yung papasok yung mainit na heat transfer fluid tas lalabas as malamig, and dahil nga doon is mag-generate siya uh, ng smoke or steam. So magge-generate siya ng steam, which is pupunta siya sa steam turbine na pag umikot, iikot yung generator, saka magge-generate ng electricity, saka na siya i-distribute. So ito, pinapakita din na ang isang water tank, dito pumapasok yung hot fluid, then lalabas as cold fluid. And sa loob, dito nagkakaroon ng steam na magpapaikot ng turbine natin. So ito naman, pinapakita yung pag-heat and pag-cool ng isang fluid. Ito naman example ng steam turbine ng isang parabolic trap. So ito example pa ng picture ng isang parabolic trap.
So, how does the parabolic trap collector make power? The parabolic collectors work as described below. First, heat transfer occurs when the solar panels warm the operating fluid, such as thermal oil, to create a high pressure steam. This transfer fluids is circulated through several absorbers. In a typical steam generator, the heat contained in this steam is turned into electricity. The fundamental structure is identical to the solar cooker. Next, the functioning of these solar power plants is also comparable to that of other power plants. They use heat to create steam, which powers engines and produce energy. The way that each power plant obtains heat differs from the other. Next is, what is HTF or heat transfer fluid? It is made to pass through the absorber tube, which converts water to steam, and then the steam is made to run the turbine to generate power. Storage of energy after sundown and low heat transfer efficiency of the HTF are the major challenges faced by solar thermal technology. So, why is HTF used instead of just heating the water directly? So, these working fluids have high heat capacity. It can maintain a high level of hotness in a long period of time. So, that is why in CSP, large volume of HTF is heated to an elevated temperature during daytime where sunlight intensity is at its peak. Then it is absorbed, it is being stored in a tight vessel. It acts as a reserve power that can be used during cloudy days when the sun's intensity is at its lowest or during nighttime, where there is total no presence of sunlight. So, what are the types of heat transfer fluids? First is air, next is water, molten salts, glycol base, glycerol base, and lastly, synthetic oils. So, the following characteristics are being considered on what type of HTF is being used in a solar thermal power plant, considering its operating temperature, life cycle, heat transfer capability, heat storage aspect, overall safety, and lastly its cost. So, the use of molten salt in parabolic trough system can heat the heat transfer fluid to 550 Celsius and has a better performance than a synthetic oils, which can heat the HTF to only 400 Celsius or less. So next is solar tower. Potential downsides of using towers such as this is that they involve large facilities that require large amounts of initial investment, as well the large field of mirrors and tower that can range up to 50 to more than 100 meters, can be seen as an eyesore and can impact the local landscape. So how does the solar tower works? As explained briefly above, a solar power tower is one of the main components of a solar power plant. This tower is placed in the center of the large array of mirrors. These mirrors can be curved or flat, but generally speaking, flat mirrors that track the sun are used as they are less expensive than curved mirrors. As this mirror tracks the sun, they catch the incident sunlight and reflect it back to the solar tower. A large number of these mirrors focus a large amount of solar radiation onto a small spot of the tower known as the receiver, heating up some fluid inside of it. This fluid is used to transfer the heat from the sunlight to the water. Old towers use steam as a heat transfer fluid, but newer designs use molten salt because of their increased heat transfer and energy storage ability. When the heat is transferred to the water, it turns to steam. This steam is then transported to a conventional turbine to produce electricity.
Solar tower, how it works. As explained briefly above, a solar power tower is one of the main components of solar power plants. This tower is placed in the center of a large array of mirrors. These mirrors can be curved or flat, but generally speaking, flat mirrors that track the sun are used as they are less expensive than curved mirrors. Yung solar tower daw is meron siyang meron siyang large array of mirrors na meron curved or flat mirrors. Solar tower is important note that these solar power towers are heat engines, as they take the energy from being warm in comparison to their surroundings and turn that heat into motion. More specifically, these solar power towers are external heat engines as the heat source is separate from the fluid that moves and does work. It is external combustion as heat from the sun hits some fluid that is then turned to steam and used to turn a turbine. So, solar tower environmental concerns. As in this case, which other solar power technology, solar power towers represent a type of electricity generation technology that is cleaner than generating electricity. By using fossil fuels, solar power towers are one of the cleanest option for generating electricity. Despite this, there are still associated environmental effects of these towers. First, a life cycle analysis shows that there are still greenhouse gas emissions associated with the fabrication and construction of the tower, as well as greenhouse gas emission from dismantling and recycling once the plant is done being used. However, these emissions are significantly lower than emission from fossil fuel combustion. Solar tower environmental concern. The water demand of these plants can also be seen as an issue, as solar towers can require large volumes of water to operate. To minimize the amount of water being used, alternative cooling technologies are being investigated, such as the possibility of using air cooling. Solar tower. The U.S. Department of Energy, along with several electric utilities, built and operated the first demonstration solar power tower near Barstow, California during the 1980s and 1990s. This is the example of solar tower. Next is solar tower. First is we have heliostats na kung saan doon magre-reflect yung sun. Next is papunta sa may receiver or sa may tower. Sunod is papunta sa hot salt, papuntang steam engine, and mag-evaporate papuntang HP turbine.
So, linear Fresnel reflector. So, what is linear Fresnel reflector nga ba? So, linear Fresnel reflector, LFR, system are similar to parabolic trough system in that mirrors reflectors concentrate sunlight into a receiver located above the mirrors. These reflectors use the Fresnel lens effect, which allows for the concentrating mirror with a large aperture and short focal length. These systems are capable of concentrating the sun's energy to approximately 30 times its normal intensity. Uh, Compact linear Fresnel reflector, CLFR, also referred to a concentrating linear Fresnel reflector, are a type of LFR technology that has multiple absorbers within the vicinity of the mirrors. Multiple receiver allow the mirror to change their inclination to minimize how much they block adjacent reflectors' access to sunlight. This position improves system efficiency and reduces material requirements and cost. A demonstration CLFR solar power plants was built near Bakersfield, California in 2008, but it is currently not operational. So sabi nga dito, these reflectors use the Fresnel lens. So Fresnel lens ang ginagamit dito, kaya tinawag siya ng linear Fresnel reflectors, also known as LFR. Diba? Kumbaga, abbreviation. No? So, which allows for continuing mirror. So, hindi normal na mirror ang ginagamit dito. High-end mirror ang ginagamit sa lahat ng mga solar power system natin. So, next So, linear Fresnel reflector. So, ito yung meron siyang secondary reflector which is yung curve na to. And then yung absorber tube, meron tayong liquid dyan sa loob, absorber tube. Ayan. And the reflector which is ang ating mirror na hindi normal na mirror. So ito yung sunlight. So para tumama yung mirror natin dun sa ating absorber tube or sa secondary reflector, kailangan natin ng mga angulo dyan. Kailangan ng angle niyan. Kasi di ba, kunyari, tumingin ka sa side mirror, meron kang nakikitang tao sa likod, which is, imagine natin, yun yung absorber tube. So, para makita mo yung absorber tube, kailangan mo ng eksaktong angle para makita mo yung nasa likod mo or yung tao sa likod mo or yung absorber tube. So, may mga angle yan. So, parabolic dish. Next na. Solar dish engine system use a mirror dish similar to a Belarusian satellite dish to reduce cost. The mirror dish is usually composed of many smaller flat mirrors formed into a dish shape. And this shape surface directs and concentrates sunlight into a thermal receiver, which absorbs and collects the heat and transfer it to an engine generator. The most common type of heat engine used in this or engine system is the Stirling engine. So, yung tinatawag natin Stirling engine, yung pala yun. This system uses the fluid heated by the receiver to move pistons and create mechanical power. The mechanical power runs a generator or alternator to produce electricity. So, malalaman natin na sa parabolic dish para ginagamit ang mga Stirling engines natin. Ano? Yung lupit din. Isan, masarap din mag-aaral. So, solar dish engine system always points straight at the sun. So, talagang straight yung focus sa sun and concentrate the solar energy at the focal point of the dish. A solar dish concentration ratio is much higher than linear concentrating system. So, mas mataas pala, ano? And it has working fluid temperature higher than 1,300 degree Fahrenheit. The power generating equipment used with the solar dish can be mounted at the focal point of the dish, making it well suited for remote location, or the energy may be collected from a number of installation and converted into electricity at central point. So, parabolic dish. Yan yung parabolic dish natin. Kung makita natin, para siyang yung, alam mo yung, parang sa TV, yung signal. Signal yung tawag sa kanya eh. Yung naka-curve siya gano'n. Tapos meron siyang gutlit sa gitna. Ganun. So parang ganun pala siya, ano. So it faces towards the sun. Lagi nakaharap sa sun yan. So components of solar parabolic. So meron tayong receiver, which is yung tinatawag, also known as antenna. Oh, yan ang receiver. So solar reflector dish, yan yung paligid. Ito, ang paligid. So meron tayong supporting structure. Siyempre, kailangan natin ng stand yan para naman mas maganda yung receive niya ng sunlight sa ating parabolic dish. So, ito yung largest thermal power station. So, meron tayong Quartzosate Solar Power Station na may capacity na 510 megawatts sa Morocco. Ang type naman nito is parabolic trough and solar tower. So, ginawa siya noong 2018 and ang area niya is 2,500 hectares. Ang luwang nun. So, meron tayong IBAN pa na may capacity ng 392 megawatts sa USA solar tower. And so, noong 2014 siya nagawa na merong 1,420 hectares. Ang luluwang, ano, di ba? So, meron tayo sa Mojave Solar Project, 280 megawatts capacity. Sa USA din, daming solar thermal power station sa USA. Parabolic trough, 2014, 714. So, Solana Generating Station na meron ding 280 capacity megawatts sa USA din. Parabolic trough, 2013, 780 hectares. So, mas maluwang siya dun sa may Mojave. So, meron tayong sa Genesis Solar Energy Project na 280 sa USA ulit. Parabolic trough, 2014 na 20 hectares. So, 1,920 hectares. Sobrang, yun ang maluwang pala sa USA na solar thermal power station. So, meron tayong last na Solaben Solar Power Station. So, meron siyang capacity na 200 megawatts sa Spain, parabolic trough noong 2012 na meron siyang 301 hectares. So, that's it. So, sana maraming kayo natutunan and maraming salamat.